learn the divisibility rules for the numbers 2 to 10. Why are these rules useful? They are really helpful when we are looking for factors of a given value. So first up we have 1260, and we are considering whether it is divisible by 2, 5, or 10. So first up 2. If the last digit is even, we know that that value is divisible by 2. Well, we see in 1260 we end with a 0, so of course we know that that is divisible by 2. I'm going to do a little tick next to the 2. What about 5? We know a number is divisible by 5 if the last digit is 0 or 5. Well, we see that our last digit is a 0. 1260 is divisible by 5. What about 10? A number is divisible by 10 if its last digit is 0. Well, our last digit is a 0. It is divisible by 10. What about the number 3? The sum of the digits is divisible by 3. Let's sum those digits together. We get a sum of 9. Is 9 divisible by 3? Of course. So we know 1260 is divisible by 3. Divisible by 4. The last two digits are divisible by 4. We see the number 60. 60 divided by 4 is equal to 15. So again, it is divisible by 4. What about the rule for 8? Half the number twice and see if that value is even. 1260 divided by 2 is 630, and 630 divided by 2 is equal to 315. Is 315 an even number? No. So we know it is not divisible by 8. I put a cross. What about 9? The sum of its digits is divisible by 9. So 1 plus 2 plus 6 is 9, so we know it is divisible by 9. I'm going to put a tick. Oh, our harder rules for 6 and 7. For 6, the number must be divisible by both 2 and 3. First up, we know 1260 is even. It is divisible by 2. Next, 3, sum of the digits was 9. Is 9 divisible by 3? Yes. So we know 1260 is divisible by both 2 and 3, and because of that, it is divisible by 6. What about 7? We follow this process. So the last digit is 0. Now 0, I have to multiply by 5. 0 multiplied by 5 is 0. Now the previous digits, I have a 1, a 2, and a 6. 126. And 126 plus 0 is 126. Now I see that my last digit is 6. 6 multiplied by 5 is 30. Now the green 30 plus the blue 12 is equal to 42, and it's a 2-digit number. Is 42 divisible by 7? Yes. 42 divided by 7 is 6. So we know 1260 is divisible by 7. Progress check. Have a go yourselves, then check your answers with mine. So first up, we test the easy divisibility rules. 2. Is the last digit even? I see a 9, and 9 is not even, so I know that 2 does not go into 37,689. What about 5? The last digit needs to be a 5 or a 0. Well, it's a 9, so 5 will not work. What about 10? The last digit must be 0. Is it 0? No, that's not going to work. Now for the slightly trickier divisibility rules. Let's see, is that value divisible by 3? Is the sum of the digits divisible by 3? And we get 33. Is 33 divisible by 3? Yes, we know that is a factor. How about 4? The last two digits are divisible by 4. Is 89 divisible by 4? Definitely not. It is an odd number, and no odd number can be divisible by 4. So 4 will not work. How about 8? half the number twice and see if that value is even. No odd number will be divisible by 8, so I don't even have to worry about that. I already know that's not going to work. 9. The sum of the digits is divisible by 9. We know that the sum of the digits is 33. Is 33 divisible by 9? No. Now, for the hardest two divisibility rules, 6 and 7. Is this value divisible by both 2 and 3? Well, already it is an odd number. It cannot be divisible by 2. So we know 6 will certainly not work. Now for the process to evaluate 7. So first we look at the last digit, 9. We multiply 9 by 5. And we get 45. The previous digits, we have 3,768. And we add the 45. And we get... Now in our new value, we see that the last digit is 3. The green 3. So we multiply 3 by 5 and we get 15. We must add that 15 to the previous digits, 381. In 396, the last digit is 6. So I'm just going to work to the left. 6 multiplied by 5, which is 30. Now I must add that 30 to 39. So 39 plus the green 30 is 69. And is 69 divisible by 7? No. We know 70 is divisible by 7. So we know 7 will not work. This is how we can check whether a number has multiple factors by using the divisibility rules from 2 to 10. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.